Hello, hi. So this video is to uh, briefly describe how does the mole concept is interrelated to all the other metric information. Okay, so to begin, the concept of mole. Now, I believe you have started to watch this video only after you have watched the other video that I've posted, the video about the mole by the TED. Now, that's a very good video that will explain basically how can we conceptualize the mole, which is kind of difficult because you cannot imagine or feel a mole of particles, unlike a gram of something or a kilogram of something. Now, most importantly, a mole, as you would have understood from that video, is a measure of a specific number of particles. Now, what is the specific number of particles? It's what we call as the Avogadro constant. It's 6.022 times 10 to the power of 23. It's also known as the Avogadro constant. Sorry about the handwriting, still getting used to this stylus. Okay, so there you go, that's Avogadro constant. Now, what do we call as particles? That would break down to a few things. Now, particles can be atoms. So, elements that exist as atoms would be elements such as metals. So, metals are able to exist as atoms, such as an example would be sodium or potassium or even calcium. Okay. We could also refer to molecules as particles. Now, what would be a molecules? An example would be most commonly halogens or other non-metals, in exception to group 18. For example, chlorine, this is halogen, or fluorine, it's also halogen. The non-halogens would be a common example, oxygen, or what else? I'm trying to think. Sulfur. Sulfur, on the other hand, is S8, and so on. Nitrogen, that's another example. Okay, anyway, moving on. Another example of a particles. This would be ions. Obviously, these are the atoms that has either lost electrons or gain electrons, such as example of sodium. It could also be chlorine. This is a lost electron, and chlorine has gained an electron. So together they form ionic salt, but individually as particles, they are just ions. So what do we call sodium chloride? Sodium chloride will go under the category of molecules. Individually, when dissolved, they form ions. So these are the category of what we call as a particle. Okay. So I'm going to try to change the color of my brush. Yep, successfully did that. So that those I'm circling in blue is what we call as the particles. Okay, right. This is the basic terminology that we use together with mole. Now, trying to relate mole concept with common metric information. So first easiest is mass. So what do we term as mass would be basically given in grams. If it's not given in gram, we have to convert it to grams. That's a must. So how do we connect mass to mole? using the molar mass information that's available on the periodic table. So from mass to mole, you basically have to divide with the molar mass. Symbol for molar mass is commonly given as mR. The unit for molar mass, which is available in the periodic table, is gram per mole. That's the standard unit for molar mass. Now, so you're dividing, and if you're converting mole back to mass, then you obviously have to multiply it with the molar mass. So you have to know this by heart. This is key. This is the most commonly given information in questions. So that would be mass. Now, how about solutions? Okay, solutions. The information that has to be given with solutions has to be concentration. We require concentration, and they would have to give us volume. Okay, so that's volume. How do we convert this information? The formula for it is N stands for number of mole, equals to C multiplied by V. C is the concentration, V is the volume, and normally we would have to divide it by 1,000, because most commonly volume given in questions would be in cm cube, but concentration has a standard unit of mole per liter. So this standard unit is mole per liter or per dm cube. That would be 1,000 cm cube would be 1 liter. All right. So this is the conversion to solution. Now the tricky one very often is going to be gas. Gases. Now gas breaks down to room temperature, which means we are conducting the experiment at room temperature and we're collecting sample at room temperature, or STP, standard temperature and pressure, and the third is any temperature or pressure. Okay, first for this we would be using an ideal gas law. Now coming back to this, RTP is quite basic. So normally at university level we rarely use RTP or STP. So generally at RTP we deem that 1 mole of any gas is equivalent to 24 dm cube of gas. Okay, so on the other hand, STP is the same thing. 1 mole is equivalent to slightly different 22.4 dm cube of gas. So these values might differ slightly depending on what syllabus are you following. For example, the Australian syllabus would, for this standard temperature and pressure, their data booklet would use 22.24. So that would vary slightly. So you would have to use the one that's given to you in yours. So, oops, okay, oops, I need to remove that. Okay, so now any temperature or ideal gas law. Now this is a bit tricky, but it's not difficult. The formula is PV equals to nRT. Now P stands for pressure, and usually is all measured in kilopascal. Volume, that's usually measured in liter. N is the number of mole, and R is 8.314. Some data book might show 8.215, so you would use whatever that's supplied in exam, and yes, that would be supplied. And temperature is in Kelvin. So how do we convert Celsius to Kelvin? We take 273 and we'll add with whatever Celsius is given to us. Okay, so this is how all three information. Now, the whole concept is about we converting any of this given information to the mole. So now the question is, why do I need to convert it to the mole? Why can't I just use the ratio of the equation directly? For example, if I were to take an equation, so A reacts with B to form, let's say it forms 2C plus 1D. So what can I just say? I've used 1 gram here, and that would give me 2 grams here. No, that's not the truth, because when reactions take place, they take place at particular levels, so at the particles. So the accurate way of measuring them is through the number of moles. So we do have to convert this metric information that's given to us, which is mass, or solutions, or gases. So we can combine these three in a single reaction if any of the product takes that particular state, and once we have converted this information, we will be able to relate it back to the equation in what we call as a stoichiometry, and that will be another lesson in another day. For now, I need you to try some of the questions as listed below. I will post another video solving at least 2 questions that would involve different units that needs to be